buffers, will be mixed with WFI in disposable containers, and its pH and conductivities will be checked and controlled until the buffers are used. The media and product will then be collected and stored in storage tanks, in which Protein A purification will then be conducted and processed further downstream. TFF helps filter large molecular weight aggregates, large proteins, and any remaining cells. As fouling is one of the major issues when using the filter, modification is done where the feed is passed tangentially over a membrane in order to prevent filter caking. The microcarriers and cells will be heat-treated per batch to 250 degrees Celsius in order to kill the adventitious cells and be disposed according to FDA regulations. Protein A chromatography acts as the first main isolation step for product and isolates the monoclonal antibody through affinity chromatography. It is useful in eliminating host cell DNA, media components, and endogenous viral particles. Cation exchange chromatography is used to reduce high molecular weight aggregates and host cell proteins. Cation exchange uses positively charged resin to bind to negatively charged particles and product while positive and neutral particles pass through. This process will require around 1.5 days. Anion exchange chromatography is also used to reduce high molecular weight aggregates, charge variants, residual DNA, and host cell proteins. Including sterilization in between batches, it will require about 1 to 1.5 days to process all batches. Viral nanofiltration is a size-based membrane separation in which proteins can easily pass through the hollow fiber walls of the membrane while viruses are captured within the pores. The filters and unit must be flushed thoroughly with WFI and be equilibrated with equilibration buffer. After viral inactivation, size-based ultrafiltration is used to remove small viral and foreign particles. A filter will be used to keep the desired product in the retentate but allow for smaller particles to be removed. Both sterilization and filtration are combined in one unit. Sterile filtration serves as the last purification step to help remove any final endotoxin, and also to help concentrate the product to the appropriate concentration. The purification or separation steps for monoclonal antibodies is sophisticated, and the overall product yield obtainable from the purification process is about 87%. In this part of the video, critical limitations associated with the design and scale-up of high-density cultures of mammalian cell bioprocessing will be discussed, along with the solutions to the associated problems. Firstly, many mammalian cells are anchorage-dependent, including the most used cell lines for monoclonal antibody production, the Chinese hamster ovary cells. Unless the cells are modified for suspension culture growth, a form of support system is required, such as microcarriers. A recent study found that the application of a fluidized bioreactor containing microcarriers increased the overall yield by 7-fold over rituximab, a monoclonal antibody drug, compared to conventional stirred tank bioreactors without microcarriers. The porous microcarriers acted as a support system and protection to the cells. In stirred tank bioreactors, cell cultures are typically exposed to physical and chemical stress. By using microcarriers, cells are more protected from shear stresses caused by the tip of the stirrer and sparged oxygen bubbles. Additionally, cells could tolerate chemical stress like lactate buildup when they grow inside the porous carrier. The next limitation is toxic accumulation, such as ammonia, which typically occurs when using mammalian cells. Hence, to minimize ammonia accumulation, the low-glutamine supplemented media is used. Additionally, in the events of cleaning up toxic accumulation, the use of appropriately sized microfiltration hollow fiber cartridge, which are steam sterilizable and easily cleanable after repeated uses, could be installed. Another limitation encountered is oxygen transfer limitation. A proposed solution is to introduce a microbubble technology and soluble surfactants in order to meet cellular oxygen uptake rate.